This is the single line diagram for grid connected solar station. Let's get into the details. Then we'll calculate each stage. First, this is the string addressing. Addressing code here has a pattern. The pattern of the addressing called string number 1, MPPT input number 1.
Inverter on the
Doctor, does anyone has any question?
I was saying that this inverter should be connected with the utility grid.
Yeah, sure,
right?
Of course.
If the grid is down, there is no electricity in the grid, this inverter will not work because it will not be able to give us the 50 hertz frequency, which is synchronized with the frequency and voltage of the grid, right?
Yes, it's designed also that way for safety cautions and don't get any hazards to the grid because no reference is there. He may be get different frequency that will harm the network at all. Cables.
So,
yes.
So this one should be synchronized. We'll use the frequency of the grid as a reference to generate the electricity from the DC. And here are the colors, which are the on the right, the S11, S12. All these cables are coming from the solar panels, right? So
yes.
The inverters.
Yes.
These are the symbols. Okay.
First string is colored by blue. Second one is colored by green, and so on to distinguish the color cable like that. This is the DC strings actually attached to the solar station. This is the first string, second one, third one, and so on. The single unit inverter has two inputs of DC. Each input called MPPT01, the second one called MPPT02. Each MPPT can operate with 3 DC strings. So I have 7 strings on 2 inverters. The first inverter has been occupied by 4 DC strings. The second one has been occupied by 3 strings only. He can take 4 more strings, but the area wasn't enough, but for 7 strings DC only. So the addressing from the right is string number 1, MPPT input number 1, inverter number 1. The next one, string number 2, MPPT number 1, inverter number 1. Here, the 2 inputs of the first MPPT. Then the 2 inputs of the second MPPT, and here the first inverter is complete and completely occupied. Then the next inverter occupied by 3 strings only because of the area, the surface area of the roof. This is the DC input. Then getting out from the inverter by AC circuit breaker and AC cable, red color. This is the first inverter. This is the second inverter. Across the MDB that we will see a few pages later, detailed main distribution board. 2 inputs on circuit breakers and 1 output circuit breaker going directly to the power transformers. How can we get the cable size for each DC input and AC output of the inverter? This catalog, before I get to the cable catalog, does anyone has any question in this part? Single line diagram for grid connected solar station? Any explanation required?
Okay.
Okay. This solar station is 50 kVA. 50 kVA distributed across two inverters, each one 25 kVA.